To recap what we did last time, we were introduced to combinations and factorial. And then we saw this magical formula. And then we saw how kind of ugly it is to write it up. And it was kind of a pain actually to find. I mean, you can do it, but it ain't pretty. But then we learned that Excel has a standard load binomial dist function. And that seemed pretty awesome. So we used that to find these probabilities. And we have that in our lovely Excel spreadsheet, what they were. And then, of course, we used them over here to find the probabilities. That's how we rolled. All right, now we're going to do it again, but with a different problem, I imagine. Oops, not there, though. Here. So it's our free thrower thing again, but instead of doing 3 players, we're going to do 5 players. See it? So what are the possible values that X can take on? Well, you can always go to 0. So for any of these questions, you always start at 0 and work your way up. So 0, 1, 2, 3, 4, 5. You got to stop at 5 because that's what your n is. You're looking at 5 players. All right. So we're going to find the probability distribution for X. We're going to use Excel to do this. So let's go make it a problem. This is number 7. So 6.2, example 7. Let's zoom in so we can see. Okay, so we're going to have X, and we need our probability of X. So I'm just going to go type those in here. Right here. There we go. Oops. I don't know what it did there. There we go. Okay, now we know this can go to 0, and I'm going to be lazy. I'm going to teach you a little trick. Now I know you could type 1, 2, 3, 4, 5. I know that, but what if you had typed to 50? It would get annoying, right? So you can use the formula I just used. Did you catch it? I start with 0, so I put 0 there. And then for the next cell, I say, hey, take that cell A2 and add 1 to it and press enter. Then I go back up, click on it, and then go to the handle and drag. And there you go. And that way you can fill in a whole bunch real quick rather than having to sit there and type 1, 2, 3, 4. And again, not for this problem. What you're learning is a technique to help you with later problems, right? Right. Okay, so we type equals binom.dist. All right, now our number of successes is right over here, cell A2, comma, we had 5 trials. Our probability of success was 0.77, comma, false. Enter. And then let me go back up on that and drag. And there you go. Now, let me just help you. You can set this up actually for kind of larger problems if you want. You can say, okay, look, my number of trials was 5. My probability of success was 0.77. Then what you can do over here is instead of saying 5 and 0.77 to yourself, you can say, okay, I want that cell, comma, that cell, but I want both of them to have dollar signs. I don't want n to ever change from 5 or that one to ever change, the probability of success to ever change from 0.77. That way I can drag it down. You're thinking, well, what advantage does that have? Well, what if I change it to 6? Boom, everything would change automatically. It means I don't have to sit there and recreate the wheel all the time. The one thing you got to be careful is that this column over here goes as high as you need it to go. So, I mean, you could drag it further if you like, and then just drag this further, and these just won't exist, right? Because you can't have 6 successes if you're only going to throw the ball 5 times. Okay, so that's a way you can make it so, watch this. Look at that, 8 throws or 5 throws, etc. Right? Makes one spreadsheet do a lot of multiple duties. Let's put it that way. All right, so we've got our probabilities. I'm going to go back here. I'm going to highlight these. I'm going to paste them in. Of course, if you don't have an Word file, you're just going to be stuck writing them yourself or typing them yourself. All right, there they are. Oops, I don't know why I did that. Now, why is that a binomial probability formula preferable to by hand methods that we learned in chapter 5? Well, wait a second here. This is 5 players, right? So every time they go up to the line, they've got 2 possibilities. That's 2 times 2 times 2 times 2, 5 times, which is 32 branches. Right? You'd have to make a tree diagram with 32 branches. You'd have to find the probability of successes and failures for every single one of those different combinations. Then you'd have to collate it all into a table ugh, right? It would be just, I mean, it's just getting worse and worse and worse. The more players you throw into this mix, the worse it's going to be for you. It's going to take a long time, and it's going to have lots of room for you to make little mistakes along the way. It's a disaster. So this formula is way better than what we were learning in chapter 5. It allows us to get all sorts of answers very quickly, as long as we know what we're doing. All right. All right, public opinion reported that 5% of Americans are afraid of being alone in the house at night. You're going to survey a random sample of 20 Americans to find out whether they are afraid of being alone at night. So why is this binomial? Well, it satisfies the properties of a binomial experiment. Namely, there's a fixed number of trials. That's what your n is. N is 20, right? You're going to go look at 20 people. They're independent. Whether I'm afraid of being alone at night has no bearing on whether you're afraid of being alone at night, right? Then there's success and there's failure. In this case, success is considered being afraid, and failure is not being afraid. And again, those are arbitrary definitions. We just chose to be that way. If you liked, you could have flip-flopped it. It won't make any difference. The probability of success is 0.05. The probability of failure is 0.95. They got to add up to 1. Now, we are going to find the probability that exactly 5 people in the same sample are afraid of being alone at night. And I'm totally going to make Excel do this for me. I know this isn't really this example, but I'm just going to find it real quick. So it's binom.dist, or binom.dist if you don't have the new version. I want 5 people that are afraid out of 20 people total. The chances of success is 0.05, comma, false. And I think I do want this in its own problem. Well, I'll just make a sheet right here. I'm just going to copy or cut and paste. As a matter of fact, let's make my life a whole bunch of different. I'm going to. No, I better show you guys again. Okay, so I'm going to simplify my life here. I'm going to find everything. I'm going to find it all, and then we're going to be able to do this. All right, so again, this is 0. This is 0, A2 plus 1. I'm going to drag it down. Now, since we're sampling 20 people, I could get at most 20 people. You'd think that's row 20, but you'd be wrong. You started at row 0, first of all, and then you have that label up there in the top. All right, now my n was 20. My probability of success was 0.05. Enter. Let me delete this for a second. Okay. So I'm going to make my life simple. I'm going to find one big table, and I'm just going to use it to answer all my questions. So to do this, I need binom.dist, binom.dist, or binom.dist. And then now my number of successes is 0, comma. Trials is 20, but give it $signs because I don't ever want it to change, comma. Probability of success, 0.05, but again, give it $signs. Hit the F4 key. So it's $E, $2, comma, false. Right? We're never going to make it, well, not never. We're not making it add them up. That's what the true would be. The true would make it add probabilities, but we don't want that. We want the individual probabilities. And then I would drag this formula down, and there you go. I've got all of them. Got it. So for part A, back here, or part B, excuse me, for part B, they wanted to know the probability of exactly 5. All right, so if we look at that for part B, it's equal to, here, binom.dist, and then it was 5, comma, 20, comma, 0.05, comma, false. That's how we found it. I'm going to put it right here. And then what is that? Well, it's equal to this value right here. Right? We want 5 successes, 5 people afraid out of 20. There we go. Oh, I better copy and paste that. Now for the next part, they want, this one was the chance of 5 successes. It was exactly 5, right? It was an exact probability. Okay, for the next one, they want at least 5. Now, there's two ways you can do that. You can do this, I'm going to do this way number one. You can add up all the probabilities from 5 on. Probabilities from 5 on. Okay, that would work. So this is why the table's so nice. If you've built the full table, which is a really nice idea, so you go, okay, well then I'm just going to add up from 5 on. So find the sum of all these probabilities from 5 all the way to 20, because at least 5 means it could be 5, but it could be 6, it could be 7, and so on. So that's one way, and I'm going to even highlight them. So 5 and beyond was adding up all of these. I'll make them like something light green. Okay, so that's one way. The other way, way number 2, is to find the sum for 0 through 4 and subtract from 1. Okay, so what do I mean by that? Well, you find the sum of these probabilities, 0 through 4, right? And then you take 1 minus that, because you know the whole column has got to make 1 altogether. And I know you're thinking, well, why would I ever want to do that? Well, when you have a computer to sit here and add 16 numbers up for yourself, it's a lot simpler. But if you don't have a computer to add 16 numbers, you might just want to add up 5 numbers and then take it away from 1, right? So it's just a little bit simpler sometimes. That's all. All right, so there's the other way. So we showed it way number 1, and we showed it way number 2. There you go. And that was the right answer right there. The 0.02 whatever. All right, awesome. I will copy and paste that in. There are a couple other ways to do it, but I think it would just muddy the waters for ourselves to try to find the other ways. So for a problem like this, once you know it's binomial, one of the simplest things you can do to make your life easy is to go to Excel, then you type in your n and your p, you make a column of x. Always start at 0, always work your way up to whatever n is. Then you find your probabilities with that binom dist formula, and then you just add up what you need, right? It's so simple to make this formula and drag it all around, right? Make every probability get calculated, everything's good. Just make sure you changed your values here to whatever it is for that problem, and make sure that if n is 20, then make sure this thing goes to 20. Don't stop at 15 or something like that. Okay, so computers really help with this. It makes it a whole lot easier than trying to do it with a calculator. Right? Calculator is much harder to work with. All right, and in case you missed it, there's a little bit of English going on here. So when you see the words at least, like we did on this one, at least 5, see that right there? That means greater than or equal to, that symbol. So what we found here was, matter of fact, I'll add a row here. To the left. So this was the probability that x was greater than or equal to 5. Like that. That's what we were finding for this one, right? For both of these, right? So what we did here was we actually found the probability that x was less than 5, and then we subtracted it from 1, right? So we said, okay, here's all the probabilities that are less than 5 right there, right? Ugh, ugly colors. I know it's not important, but it's important to me. Stop that. There we go. So we found the probability is less than 5, and then we took it away from 1 to find the actual answer we were looking for, using that complement rule from chapter 5. Okay. More than is greater than, fewer than is less than. At most, the words at most, that's a less than or equal to. All right, we're all done with this page. I'll see you back here for the next page.